This video is going to show the process of making a small plumb bob on the metal lathe. This is the first finished product that I successfully created, although it went through a few iterations in the building process that you'll see. It was not immediately successful in every regard. But here I'm roughing out the outside of a scrap piece of brass that I had sitting around. And facing it off, making it all the surfaces square and round and concentric so that I have a good way to hold on to it later on. And all these clips are sped up 16 times. It's much slower than this in real time. Here I was drilling out the center. I had the idea of having a steel tip on this plumb bob, just because I thought it might look cool, but the plumb bob tip doesn't actually see much wear, so it doesn't need to be a harder material than brass. Here I'm starting to cut the taper to form the point of the plumb bob. I decided to rough out as much of this as possible before putting in the steel tip. Here's another angle of that same process, finishing it up. Brass turns really nicely when you have a tool ground to the correct geometry. Makes lots of nice little chips. Here I'm using a dial indicator to measure the runout, which is the amount that the plumb bob is not running concentric to the axis of the lathe. I've already hammered the steel tip into that hole, and I'm trying to make sure that it's all running concentric so that when I start turning the taper down onto the steel tip, the steel will be centered and the ring it forms with the brass will be round. I'll explain more of that later on, but it might make more sense, I hope. The dial indicator measures distances, minute changes in that little ball up in the upper right-hand corner. And what I'm doing is seeing how much the ball is moving and then adjusting the lathe chuck to compensate until it's moving the smallest amount possible, which here is 2/1000 of an inch, which is a little less than the thickness of a sheet of paper. Here I'm starting to turn the taper on the steel tip. You'll see that it's a different turning tool. Steel uses a different cutting geometry than brass, or steel cuts better with a different cutting geometry than brass, and there's also oil on it. Steel requires lubrication when cutting. It's actually hard to turn steel and brass at the same time, I found, because it's really a compromise. It's hard to use the same tool on both. Here I'm starting to work the tapers together, the taper in the brass and the taper on the steel point. This took a lot longer in real time. Especially because this lathe doesn't have power feed on the taper cutting axis. It only feeds automatically when cutting a perfect cylinder or the end of a cylinder. Here you can see more what I mean about the joint between the steel and the brass being round. If the steel isn't perfectly centered in the brass, when you cut a cone that intersects with that joint, the joint will be an ellipse, or a slightly distorted one. And you can see that here, how the line that forms that seam is not exactly perpendicular to the axis of the center of the cone. And that's because the steel is a little bit off-center. And when I'm stopping here, I'm adjusting that to ideally get the point figured out. But then this happened. I guess I went a little bit too thin, or my hole wasn't quite deep enough, or I should have used a different adhesive or a tighter fit. Anyway, I gave up on the steel point and started extending my taper back onto the brass. Just going to make a entirely brass plumb bob to start out. And here you can see those lovely brass chips as they fly off. As I get closer to forming a real point, I can adjust the tool closer to center because I have a reference for what center actually is. And it becomes more important that the tool is perfectly centered when you're cutting smaller diameter things. A smaller distance from center can be a larger percentage of the diameter. Here I was running out of travel, so I cut the bottom part of the taper and finished it, and then moved the whole carriage over and cut the top part of the taper and blended them together. Here's a wider shot so you can see what I'm doing operating the power feed. Here I've started to form the cylindrical part of the Plumb bob. My right hand's operating the half nut lever that locks the carriage onto the lid screw to feed it forward. Here I'm finishing up the surface of the taper with a file because I was not super happy with the quality of the cut right off the tool. I also added 3 decorative grooves. I think I ran out of memory when I was filming those. And here, finishing it up a little bit more with some emery paper. Here I'm attempting to use a form tool, which is any tool that imparts its form onto the work. So you just sort of plunge it right in. It did not go very well. I was just trying to dress this up a little bit with some decorative coves. This lathe, while it's big, is a little bit small for this kind of material removal, interestingly enough. But it made some really interesting little needle-like brass chips. And then here, finishing up the insides of those areas with a round file and more emery paper. Here I'm polishing it up a little bit with some 3M machine polish, which, well, it wasn't really prepared well enough to have a truly mirror finish, and that wasn't the goal, but it just made it a little more interesting. Here I'm attempting to part off the excess. I flipped the part around in the chuck, so the point is now pointing away from us. This lathe, again, doesn't really have the power for this kind of thing, and I was having problems with the motor where I kept tripping the GFCI protected circuit. You'll see the lights go off every time it stops. I was getting so fed up with that that I resorted to a hacksaw and just cut it off by hand, which was much faster in the long run. There I'd had it for the last time, and it was getting to the point where I couldn't even turn on the lathe without it tripping the breaker. I'm not even sure what changed, but I stole a motor from another one of my tools and got it up and running again. So it was a problem within the motor that I still have not solved. But here I'm turning it to the final diameter and facing off the top part as the point hangs down. And cutting a little bit of a chamfer on the top of the Plumb bob, 45-degree taper. Here I'm drilling it out to accept a bolt that will ensure that the string is perfectly centered, and you'll see more what I mean later. I'm drilling it out a little bit undersized. I think this was 15/64, so I could tap it for a 1/4-20 thread. Here's the tapping by hand, just cutting an internal thread. And you can see that a 1/4-20 bolt threads right in there. Here I'm using a center drill to mark the center of a 1/4-20 bolt. This is necessary when using long, thin drill bits that have a tendency to wander, and here I'm drilling out all the way through the center of that bolt. The string will get tied through that hole, and then the bolt threaded into the top of the Plumb bob, and that's what keeps the string centered with no visible knot. This is actually a very deep hole for this size drill bit, and this bolt is mild steel, which is relatively hard, so a lot of backing out to clean the chips, a lot of oil, cleaning the chips away with a brush, which is safer than doing it by hand. And here's the finished thing put together. The bolt threads in, a little bit of a nice color contrast.